Let's talk about molar masses or molecular masses and what they are. Well, if we look at our periodic table, we know that we have atomic masses on some periodic tables written above the elemental symbol, and on some it's written below. It's the one that has a lot of decimal places. So if you look at your periodic table now and you check out carbon, carbon has 6 protons, and then above it will be written 12.01. Now what does that 12.01 mean? Well, that's actually the mass of this element. So it's in a weird unit as well. We've talked about AMUs before, atomic mass units. We talked about these, we discussed these when we were talking about the isotopes. Well, they're back. We're not going to be calculating any of the isotopic nature of each element or anything like that, but we are still going to use the AMU for about one slide. And then we're going to change that unit to something that's more useful to chemists. So the number that's written on the periodic table is called the atomic mass, and its units are AMUs. So carbon itself would be 12.01 AMUs. For any mass that you would weigh out, you could get 12.01 AMUs. So in order to calculate the molecular mass, let's say we had H2O, all we would have to do is we'd have to multiply the subscripts of each of the elements by the atomic masses found on the periodic table. So in this case, we have 2 hydrogens and 1 oxygen. We would multiply 2 times the atomic mass found on the periodic table for hydrogen, plus 1, since there's only 1 oxygen, times the atomic mass for oxygen, which would, in this case would be 16. So let's see how that works. This is exactly what I said. We write a simple formula. Molecular mass is equal to the number of each element times their atomic mass, and then added all the way down the entire compound. So there's 2 hydrogens, 1 oxygen. We look up on the periodic table, we see 2 hydrogens is 1.008 AMUs, and we're going to add to that 1 times the atomic mass of oxygen, which is 16.00 AMU. Now, depending on which periodic table you're looking at, your numbers might be slightly different. What that means is our significant figures at the end might be different when we add up our molecular masses, and that's okay. This ends up being 18.02 AMUs total for the water molecule. We know that we have to have 2 decimal places here because we're doing the multiplication first. This is an exact number, so it has an infinite number of decimal places. This is not an exact number, so it has 4 significant figures. If you multiply these 2 things together, you end up getting a number that will have 4 significant figures, or 3 decimal places in this case. If we do the same thing for 1, 1 is an exact number. We multiply it by 16.00. There are 4 sig figs here, but only 2 decimal places. So when we add these 2 numbers together, we end up getting a number that has 2 decimal places, but a total of 4 significant figures. And that's all there is to it. Generally what will happen is on the periodic table that I give you, you will be able to record up to 4 significant figures for each of the elements. Now that may change based on the periodic table that you're looking at, but that's what's known as the molar mass or molecular mass. We multiply the number of each element times the atomic mass for each element, and sum up each of the elements throughout the molecule.